welcome to Learnoversity. In this lecture, we are going to cover properties of Laplace transform. And first property is linearity, second scaling, time shift, and then frequency shift. We are going to cover these four properties in this lecture. First is linearity. Laplace transform of f1t is equal to f1s. Laplace transform of f2t is equal to f2s. Okay. Then Laplace transform of A f1t plus B f2t is equal to A f1s plus B f2s. Means linear combination of two signals in time domain is equal to linear combination of their Laplace transform. Okay. Next is scaling property. Scaling, in this property, Laplace transform of f1t is f1s, then Laplace transform of f1 of at is equal to 1 by a f1 of s by a. Okay. Next is time shift. In time shift, if Laplace transform of ft is equal to fs, then Laplace transform of f of t minus a is equal to e raised to power minus as into f of s. Okay. Next is frequency shift. In frequency shift, if Laplace transform of ft is equal to fs, then Laplace transform of e raised to power minus at ft is equal to f of s plus a. Now we will do proof of all these properties one by one. First is linearity. Laplace transform of ft is fs, and how can we write it by definition? 0 to infinity ft e raised to power minus st dt. Okay. Then Laplace transform of a f1t plus b f2t is equal to, how can we write it by definition? 0 to infinity. फंक्शन क्या है हमारे पास? पूरा ये वाला. तो a f1t plus b f2t e raised to power minus st into dt. Right? Now separate these terms. 0 to infinity a f1 t e raised to power minus st into dt plus 0 to infinity b f2 t e raised to power minus st dt. Okay. This a and this b, these are constant values, so keep these values outside the integration. A 0 to infinity f1 t e raised to power minus st dt plus b 0 to infinity f2t e raised to power minus st dt. Right? Now see, what is this function? This is f1s. If we compare it by the definition, this one a, so we can write it a f1s. Okay. Plus b. Now what is this? This is f2s. b f2s. Right? And this is the expression which we want to prove. See from this side, Laplace transform of a f1t plus b f2t is equal to a f1s plus b f2s, and we have proved it. Right? Now second property, that is scaling. Laplace transform of ft is equal to fs, that is equal to 0 to infinity ft e raised to power minus st dt, as we know it by the definition of Laplace transform. Now, as per scaling theorem, Laplace transform of f1 at, Laplace transform of f at is equal to 1 by a f of s upon a. Let's do its proof. Laplace transform of f of at, by definition, how can we write it? 0 to infinity f of at e raised to power minus st into dt, right? Now let us suppose at is equal to x. From here t is equal to x upon a and dt is equal to dx upon a, right? Now put all these values in this expression here. What will we get? 0 to infinity f of at is equal to x. We assume here e raised to power minus x and t is equal to x upon a. X upon a and dt is dx upon a. Dx upon a. Right? Now see, 1 by is constant, so keep it outside the integration. 1 upon a, 0 to infinity, fx e raised to power minus s upon a into x dx. Okay? Now compare it with basic definition. Right? See, this expression is in terms of t and this expression is in terms of x, but it doesn't matter. See the expression of t here, this is s and we are writing it fs. This s is same as this s. Can we write this expression as 1 upon a f of s upon a? Because this s upon a is equal to this s upon a. Okay, and this is the thing which we want to prove. See, Laplace transform of f1 at is equal to 1 upon a f1 s upon a. Right? Now next property is time shift. If Laplace transform of ft is equal to fs, and by definition we can write it 0 to infinity ft e raised to power minus st dt, right? Now see this property, Laplace transform of f of t minus a is equal to e raised to power minus as fs. ये हमें प्रूव करना है. f of t minus a, it is a delayed function, it is time shift. Here t is equal to 0 and here t is equal to 8, means टाइम के अंदर शिफ्टिंग हो रही है. इसको हम प्रूव करते हैं. Laplace transform of f of t minus a is equal to, by definition, 0 to infinity f of t minus a e raised to power minus st dt, right? Now let t minus a is equal to x. From here t is equal to x plus a, right? And dt is equal to dx, because a is constant value, right? Now put these values in this expression here. Let's put it 0 to infinity f of x, t minus a is x, and e raised to power minus s, t is x plus a. You can see here x plus a and dt is dx, right? Now 0 to infinity f of x e raised to power minus xx, इसे ओपन कर रहे हैं हम, into e raised to power minus sa dx, right? Now this expression is in terms of x, and see this term e raised to power minus sa, it is constant. So keep it outside the integration. E raised to power minus sa, 0 to infinity, fx, e raised to power minus sx, dx, right? If we compare this expression with the basic definition of Laplace transform, then we can write this expression as f of s and multiply by this constant term e raised to power minus sa. We can also write this term as e raised to power minus as f of s, and this is the expression which we want to prove. See here, Laplace transform of a delayed function f of t minus a is equal to e raised to power minus as fs, right? Now next property is frequency shift. Laplace transform of ft is equal to fs, and by definition we can write it 0 to infinity ft e raised to power minus st dt. Okay. Then Laplace transform of e raised to power minus at ft is equal to, by definition, how can we write it? 0 to infinity e raised to power minus at ft e raised to power minus st dt, right? Now 0 to infinity ft e raised to power माइनस, दोनों को कंबाइन कर देंगे, माइनस ऑफ s plus a into t dt. Now compare this expression with the basic definition. Then how can we write this expression as f of s plus a? And this is the thing which we want to prove. Laplace transform of e raised to power minus at ft is equal to f of s plus a. Means if any function in time domain is multiplied by an exponential function, that is e raised to power minus at, then its Laplace transform is fs, but s is equal to s plus a. Let's take an example. Laplace transform of sin omega t is equal to omega upon s square plus omega square. Then Laplace transform of e raised to power minus at sin omega t is equal to, from this equation, how can we write it? Expression will be same, of omega upon s square plus omega square, but put s is equal to s plus a. Okay. Then what will be the result? Omega upon s plus a square plus omega square. Right? This is all for today's lecture. In next lecture, we are going to cover differentiation and integration properties. Thank you.